All right, check out this guy. This guy's a nice tamale. Trying to verify cosine of x minus cosine of y. Okay, so notice the different variables, meaning these really don't have a common term together, so we're not going to really, we got to deal with them separately, okay, with their own types of variables. So cosine of x minus cosine of y all over sine of x plus sine of y plus sine of x minus sine of y all over cosine of x plus cosine of y. Does that all equal 0? Yes. Okay, we're done with the problem now. Okay. And we got to show, right? We got to verify and show that this really does equal 0. And we're going to do the same thing that we did in the previous example, which is we need to find a common denominator. We're going to combine these two terms together. So our common denominator, if this side is sine of x plus sine of y, and this side is cosine of x plus cosine of y, the common denominator is when we multiply these two together. Okay, so the way I'm going to start this is I'm going to just start with my common denominator. Sine of x plus sine of y, cosine of x plus cosine of y. Okay, so when I multiply these two terms together, this dude and that guy, when I multiply those dudes together, that's my common denominator. All right, so that means this side I have to multiply by cosine of x plus cosine of y. Okay, so that's why I'm multiplying on this side. Cosine of x plus cosine of y. And this I'm multiplying by sine of x plus sine of y, right? I mean, this is top and bottom, but I'm not doing the denominator right now. Okay. So if I do the FOIL method, cosine times cosine is cosine squared. But then, like, if I do cosine times negative cosine, it's going to be a cosine x negative cosine y. Then I multiply these guys, positive cosine y, positive cosine x. So they just cancel. So basically, do you see that this is a difference of two squares? I just squared the first one, cosine of x squared, and then I square the second one, minus cosine of cosine squared of y. Okay, so if you were to FOIL all that, then this is what you'd get. Same thing over here. If I were to square, this is like a minus b, a plus b. So that means I'm going to get sine squared of x minus sine squared of y. And that's it there. Good. So check this out now. Cosine of x squared plus sine of x squared. These two guys, if I take their sum, cosine of x squared plus sine of x squared, well, that's one of our identities. That's just one, so I'm going to put 1 right here. Okay, and we have our common denominator. Again, sine of x plus sine of y all over cosine of x plus cosine of y. Okay, so look, this right here is 1. Now watch this. This is negative cosine of y minus cosine of y squared, right? So we don't quite have an identity for that, but what if I factored out a negative 1? I did minus 1, and then I did cosine squared of y plus sine squared of y. Well, what is cosine squared of y plus sine squared of y? Isn't this all right here just uno? So really it's just 1 minus 1, right? Because 1 times 1 is 1. So 1 minus 1 is 0. 0 over this whole thing. And what's 0 over any denominator? Well, that's going to be 0, and that's exactly what we were trying to verify. So a little bit, a bit tricky there. You might want to rearrange these and see that, but basically we just did our Pythagorean theorem, our Pythagorean identity twice, and we got 0.